So I'm going to leave the class code up there because on these class kicks, you can always go back in them. So you can always go back and check these later should you obviously you might want to screenshot and pull in because these are good review questions. But you can always go back to these class kicks because if you use the same device, it'll remember your login and then you just type back in that class code. So number 1 said find the volume of the solid with the regular pentagonal bases, right? So it says it in the directions. It won't always. It'll either give you the picture, you got to figure it out, or it would give it to you without a picture. But we know the bases are a pentagon. So with the volume of, this would be a pentagonal prism because there's 2 bases. So the volume is the base area times the height. The base area is what changes depending on the shape of the base. This base is a pentagon, so we find the area of a pentagon by doing 1/2 A and S. So if I use this or the back, those would be the bases. A is that little apothem that they gave you was 10, so this is my apothem. Number of sides is 5 because it's a pentagon. And then the length of each side. So these are congruent bases, which means the front and the back are the same. So if they gave you the side length on the back, it's the same as the front. So 14.5 is your S. Multiply that out, and you get 362.5. And then multiply it times the height of the prism, which is 15, and you should get 5,437.5. Good job, Matt. Yeah. Right? So let's say it gave you this, but it didn't give you the direction on the top where it said pentagonal bases. From the picture, you have to know that that's a pentagonal prism. All right, number 2, find the volume of a right triangular prism with height 32, base height 12, base length 18. So the base height and the base length are telling you that those are the segments of your right triangle. So I drew it on there for you, but make sure you know how to draw these things out because you're not always going to get a picture. So the right triangle would be the base. Again, this is a prism, so volume equals base area times height. This time the base is a triangle, so 1/2 base times height, and that's base of the triangle times the height of the triangle. So base and height are 12 and 18. 1/2 of 18 times 12 should have gotten 108. And then the height of the prism is 32, and 108 times 32 is 3,456, which would be the volume of this solid. Good job, Leah. Matt.
Okay, so whenever it's talking about a prism and it says like the shape for the prism, so
That's the base.
That's always the base?
Yep, that's how you name a prism, by its base.
You probably said that.
Probably. That's okay. That's all right.
I'm getting it.
That's okay. At least you don't like say like you never said that. At least you acknowledge I've said it. You just didn't listen.
See, I didn't know. You didn't know that.
So here's the catch. You're either going to get the name of it and no picture, or a picture and no name. You've got to know how to do both.
Say that again?
So you're either going to get the name,
Oh, you'll get the picture, not the
or you're going to get the picture. With the name, you have the hard time drawing the picture, right?
Yeah.
Or you get the picture and you don't get given the name of it. So like, you got to figure out what the shape
We'll
is.
give you the numbers on the picture.
Yeah, so like let's pretend it was like this, the last one, but it didn't give you... Okay, third one. Find the volume of the right cylinder. This is where you get to breathe because cylinders are nice and easy, right? So the volume of a cylinder is pi r squared h because it's base area times the height. This time they gave you the diameter, so you had to cut the diameter in half to get the radius, and then 7 squared, 49. 49 times the height, which is 30, gave you 1,470 pi. You're going to keep these in terms of pi. Good job, Claudia. Raise your hand if you got at least the cylinder right. Come on, folks. Okay, good. All right, this question, and I said this is a really good standardized test question. It says a cylindrical beaker with a diameter of 10 inches and a height of 12 inches is filled with water that's then poured into a rectangular pan that is 14 by 9 by 3. What's the volume of each solid? Would the water overflow in the pan? And if so, what's the height of the water in the beaker after the pan is filled? So first, baby steps, right? The cylinder. So if you want to find the volume of the cylinder, you had to take the diameter, cut it in half, which is 5. 5 squared is 25. 25 times 12 gives you the volume of the cylinder is 300 pi. Then it says it's filled in the water's then poured into a rectangular pan. So if you could picture a rectangular pan with a lid, if it was solid, it would be a rectangular prism, right? And the volume of a rectangular prism is length times width times height. So 14 times 9 times 3 gives you 378 inches. And then it says, would the water overflow the pan? So if I took my cylinder and I poured it into the pan, is it going to overflow? Yeah, 300 times pi would be 300 times 3 something, right? So this is a number that's bigger than 900. With 900 cubic inches of water, it's going to overflow a 378 cubic inches pan, right? And then if so yes, it would overflow. If you wanted to know what it was, then I would have to multiply 300 times pi, 3.14, let's say that. Subtract from it the 378, and I would get the remaining liquid that would have to be poured in. So then it said what would be the height of this cylinder after it's poured out. I would get the volume equal to pi r squared h. We still know the r, we just don't know the h, and we'd work backwards. Alexis?
So the test, did you want us to multiply times 3.14?
No, on the test, if you got a question like this, you would be instructed I would let you have a calculator so that you could get to the end, because you can't work backwards. You could answer something like, what would be left? And for that, I would just say I would take 300 pi and subtract from it 378, leaving it in terms of pi. But I wouldn't expect you to then work from there to get to the height.
Yeah.
Probably not on your chapter test, no, but that's a really good standardized test question. That's why I want to talk about it, yeah. And yesterday I told you we would talk about, we're not going to put oblique shapes on your test, okay? But an oblique shape, if you look in your book, there's a theorem, I think it's like Cavalari's theorem or something, that basically says if I had a rectangular prism filled with water and I poured it into a cylinder that has a rectangular prism that's slanted but has all the same volume, they would match. So whether it's a right rectangular prism or an oblique rectangular prism, the volumes are the same. So we didn't work through that example yesterday, but had we, they're the same. So if you treat a right rectangular prism the same, or cylinder, the same as you would an oblique, okay? So if it ever comes back again. Oblique is like slanted. Like slanted. Like this is straight up and down, that's a right cylinder, right? If I slanted it, it's called oblique, and it has the same volume. So you just need to know they have the same volume. It probably won't be on your test, but you just need to know they would have the same volume. So we did prisms and cylinders together because a cylinder is basically a prism with a circle as its base. And we're doing pyramids and cones together because a cone is pretty much a pyramid with a circle as its base. So they're related. Okay, we're going to learn two formulas today, which are the volume of a pyramid and the volume of a cylinder, of a cone, sorry. So information about a regular pyramid, and some of this stuff we've already talked about. It has one base, which would be a regular polygon. So if it's a square pyramid, then it's a regular quadrilateral. If it's a triangular regular pyramid, then the triangle is an equilateral triangle. If it's a hexagonal pyramid, that's a regular hexagonal prism, then your hexagon's a regular hexagon. Which makes all the lateral edges congruent, all the lateral faces congruent, and they would all be isosceles triangles because the lateral edges are congruent. And then the altitudes meet the base at its center. So in a regular, let's say this is a square prism, the height and the altitude are the same. They go from that top point straight down, hitting it at its center. All of the lines connecting that vertex to the base edges are congruent, and those four triangles that form the lateral faces would all be congruent isosceles triangles. because it's not a full shape. You're missing all those sides, right? So think about taking a pyramid and sliding it into a rectangular box.
Okay.
You have all that extra space, right?
Yeah.
So we account for that extra space by cutting it
Dividing
by
it
a third. Mm-hmm.
Okay, just pyramid triangle.
Yep. So the volume of a pyramid is 1/3 the base area times the height. So you're taking your prism and you're multiplying it by a third. B is the area of the base. So again, depending on the shape of the base of this pyramid, will depend on how I find B.
So you do it the same way, just in the end you're just dividing by 3.
Yeah.
So it's the same thing, just dividing by 3.
Yeah.
Alright.
Alexis.
Is it gonna be where, when it gives you the value, like, to try to find, like, another part in the equation? Like, are we gonna have to, like, can we leave it in, like, the 1/3 thing, and we have to, like, get a bunch of decimals and things like that?
No, so you'll either have a number that's divisible by 3 in which you'll divide 3 into it and get a nice number, or you'll leave it over 3. You won't give me a decimal here. So I want the answer to be exact, and almost nothing can be divided by 3 and round, like you can't, there's no 0.5 in a divided by 3 situation. So you'll either divide it evenly into it, or you'll leave it over 3. Okay? The volume of a cone. So because the B on a cone is a circle, and that B is, the area would be pi r squared, the volume of a cone is 1/3 pi r squared h. So we simply just replace the B with pi r squared because the base is a circle. Good. So notice that the height, we're using the height here, and when we did surface area on cones and pyramids, we used the slant height. So this is where a lot of that Pythagorean theorem is going to come into play. You're going to get given a shape and asked to find the surface area, the lateral area, and the volume of it, which means on a prism, height is height. There's no such thing as slant height. But on a cylinder and on a cone and a pyramid, you're going to have to find the h, God bless you, to find the volume, and you're going to have to find the L or the slant height to find the area. So there's going to be a lot of right triangles in your future. A square pyramid has a base edge of 6 centimeters and a lateral edge of 5. Find its volume. Give an exact answer, which means don't round it. Okay? So, square pyramid. Base edge. What's the base edge? What's the base? The square. So all the edges of the square, they're telling you are 6. And the lateral edge is the segment that goes from the vertex down the side. So this is 5. With me so far? Yep. So for volume, 1/3 base area times the height. So I have to find the base area, which is the easy part, right? This is 6 times 6. Where'd you get the 180? The lateral edge is not the same thing as the height. Where's the height go? From the vertex down to the center. So there's 2 different ways to get it actually. One involves the radius of your square being one leg, the height being the other, and the lateral edge being the hypotenuse. The other way is half the side length, picture going that way, the height, and the slant height. Both ways, you still have to find one more measurement. If I'm using the first one, I have to find the radius. If I'm using the second one, I have to find the slant height. In this case, it's going to be easier to do the slant height. Because if I cut 6 in half, I have this segment here, which would be the apothem of that square. Okay?
So if it's regular, you just cut the thing in half.
Yep. That's the apothem. Yep, on a square. Regular square. Okay? And then slant height. Remember, slant height divides this into 2 triangles. And this lateral face, which I've now drawn all over, had an edge in the two lateral edges of 5 and the bottom is 6. What happens when I draw the altitude of that triangle? Cuts the bottom into 2 equal parts. This is 3 and this is 3. And Ava, what's the missing side? 4. So that's my slant height, which honestly, in most problems, you're going to eventually have to find anyways, because these things are going to ask you for volume and surface area. So this is 4, and this is 3, and now I have another little right triangle where that 4 is my hypotenuse, and the bottom is 3, which is your apothem. So now I have to use Pythagorean theorem because that's not a triple. If 4 is the hypotenuse, it's not a triple, right? 3 squared plus the height squared equals 4 squared. H squared would equal 7. And the height of this pyramid is the square root of 7. So now volume equals 1/3 the base area, which is 36, times the height, which is root 7. 1/3 of 36 is 12, and I'm going to keep this exact just like it told me to, so I keep it in terms of that square root. Centimeters and volume is cubed. A regular triangular pyramid. Okay, ready for some drawing? Let's start with, I don't know why, but with a regular triangular pyramid, I tend to start with the base. I start with the triangle. And then I go up from here. Yeah. So the green is the base, and the blue would be the base edges. Well, pretend it's 3-dimensional. I can't help you there. I can't make your 2-dimensional shape or a piece of paper on a test look 3-dimensional. All right, so slant height is 9 centimeters, which means the segment that runs down the side of any one of these lateral edges would be 9. And the base perimeter is 12. So if the base perimeter is 12, what's the length of each of those green sides? Good. Find its base area and its volume. So start with the equilateral triangle. I'm pulling out the base so that we can look at it as though it was just 2 dimensions, because that's how I have to start. I have to start with the base area. So I just heard you say it, but this is a equilateral, which means 60, 60, 60, right? Cut it in half. 2 ways to look at it: a 30, 60, 90 triangle, or it's an isosceles triangle with an altitude, which cuts this into 2 congruent parts. So you can either use your 30, 60, 90 triangles or your Pythagorean theorem. Opposite the 30 would be the 2, which is your A. Opposite the 60 would be A root 3 or 2 root 3. And then opposite the 90 is 2A, which is your 4. So whether you use your 30, 60, 90 or you use your Pythagorean theorem, doesn't matter, you'll get the same answer.
I'm scared of those roots.
So that 2 root 3 is the height of the base. So this is a triangle, which would be 1/2 the base times the height of the triangle. I'm still just focusing on the base, which would be 1/2 4 times 2 root 3. And then the 1/2 and the 2 cancel out, and the base area is 4 root 3. Alexis. The 4 is the side measurement on that equilateral triangle, which would be the base of the equilateral triangle.
Oh, because it's a lowercase p?
Correct. So this whole thing is just talking about the base of it. I haven't even gotten to the rest of the pyramid. Questions so far? Okay, so if I want to find its volume, I'm missing what? The height. So the height of this, I have this slant height. I'm missing the height. What's that little segment that would connect? Nope. That's for a square. You asked me and I said a square. What's the little segment that goes from the center to the side? The apothem. So I have to find the apothem of that little triangle, the base, okay? What?
Oh, okay. I got it.
Oh, okay.
Wait, I thought there was another triangle.
Oh, boy.
Did I miss that?
I don't know. I don't know what triangle you're talking about.
That's just the base. You just pulled up the base.
The one on the left, I just pulled up. The one on the left is the base. So I just drew the base to the side so that we could look directly at the base.
Okay. Okay, I got it. Okay, I just thought there was something different.
So I'm finding this, which is the apothem, but I'm going to find it over here because it's the same thing just drawn over here, okay? So I need to find the apothem.
Are questions like this on the quiz?
I put a triangular pyramid. I think I put a square one. But yeah, you have to find the height, the slant height, because you have to find both area and volume. All right, so what happens to that little, think about your equilateral triangle. Yep.
Really, when you say like the apothem goes to the side, does it split that side like in half?
It does.
So it's always like directly across, like it can never be like.
Correct. Of a regular pyramid, which is all these are regular.
Okay.
Yeah. All the things that we knew about polygons, all that 1/2 A and S, all the stuff we apply to that are now just applied to the bases of these things.
Okay.
So that's my A, right? So if you think about your equilateral triangle, if we drew the little central angle, this was 360 divided by 3, which is 120. We cut it in half. The top angle was 60. The right bottom angle was 30. And this would have been A root 3. This would have been A. So if 2 equals A root 3,
You're not.
then this is my apothem. Yep.
With Welch's.
Okay, so I just worked that whole time to find the apothem, right? Which is here.
Teachers and students is part of the eruption. You have your affection rate. We know that there's been some rumors spreading around the school.
All right, let's finish this one. So I have the apothem. So if I pull out this little triangle, this bottom is 2 root 3 over 3. And the hypotenuse is 9. And what I'm trying to find is the h. So h squared plus 2 root 3 over 3 squared equals 9 squared. The 9 is the slant height, which was the hypotenuse of that triangle.
Are we gonna have one too like that crazy?
Yes, especially because you keep whining about it. 4 times 3 over 9. We're going to run out of time, so I'm going to finish working through this just so that you can get an idea of what would happen so you understand the steps. Obviously, the same exact numbers will probably never show up again because that's not the way it works, right? You have to understand the steps to it. Don't pack up yet. Hang on, because we haven't even done a cylinder one. I mean a cone. All right, so once I find the height of this, so once I complete this little triangle, and again, I'll work through it, but once I find that, then I would just do 1/3 times the base area, which we found here, times the height, which is what we're going to get over here, okay? So the numbers may not always divide evenly. It doesn't mean you get to stop, okay? And it may not always be the most obvious thing, but at some point you've got to be able to try them enough to get there because, like I said before, no matter if it's volume or it's surface area, you're going to end up having to find slant height and height. All right, so after reviewing the homework and the problems on the quiz, I'm going to change that last example so that it's a little bit easier. So this is a regular triangular pyramid, pretend that's a height of 9 centimeters and a base perimeter of 12. So again, if I start with a triangle as its base, these would be my lateral edges. This time, let's say that this height is 9, and then the edges on the base, because the perimeter is 12, divide that by 3, and each one is 4. So for volume, I need 1/3 base area times height. This base is still an equilateral triangle, so I would still walk through the same steps I did before with either doing 60, 60, 60, cutting it in half. And then I can do, this would be 2 and 2. I can do the Pythagorean theorem or the 60, 30, 90 triangle. So if I do Pythagorean theorem, it would be 2 squared plus the height squared would equal 4 squared. 4, 16, h squared would be 12. And so the height here would be the square root of 12, which is 2 root 3. That's the height of the triangle on the bottom, and then the base, which is the base area, 1/2 the base of the triangle, which would be 4, times the height, which would be 2 root 3. 1/2 of 2 cancels, and I get 4 root 3. So that's the area of the base. So now pretend that they gave you the height instead of the slant height. I would get the volume equals 1/3 4 root 3 times 9, which is the height. So 1/3 of 9 is 3, and 3 times 4 is 12 root 3 centimeters cubed. All right, example. The height of the regular triangular pyramid is 6 centimeters, and the radius of the base is 8. So, again, volume, 1/3 base times height, and we got to start with the base area. So I'm going to redraw this. If you could picture the base being an equilateral triangle, because that's what a regular triangle would be. And this time they give you the radius is 8. So if I start the same way we did before, this is a regular polygon, so 1/2 ANS is going to give me the area of this. Divide 360 by 3. This whole thing is 120, making this 60, 30, 90. So this is 2x, this is x, and this is x root 3. If 2x is 8, then x is 4, which makes your apothem 4. And then half the length of the side would be 4 root 3. The whole side would be 8 root 3. So then if I want to find the area of the base, it would be 1/2 the apothem, which we just said was 4. The number of each side, it's an equilateral triangle, so it's 3. And the length of each side, 8 root 3. 1/2 of 4 is 2. 2 times 3 is 6. 6 times 8 is 48 root 3. That's your base area. And then it says the height is 6. So volume would be 1/3 48 root 3 times 6. 1/3 of 6 is 2. 2 times 48, 96 root 3. This time it's centimeters cubed. So base area would be centimeters squared, and volume would be centimeters cubed. All right, now we've gotten a cone. So cones, hopefully these are a lot easier. The B on a cone would be the base area. The base is a circle, so it would be pi r squared. And then volume is the base area, or 1/3 the base area times the height, which is 1/3 pi r squared h. So if the entire distance from one side of the circle to the other, which would be the diameter, is 24, that means the radius is 12. So the base area would be pi times 12 squared, or 144 pi meters squared. And then the volume would be 1/3 144 pi times the height, which is 13. So 1/3 of 144, 4 goes into 14, 3 goes into 14, 4 times 24, 8 times, and then I would get 48 times 13, 624, and the pi still there, meters cubed. and then divide by 16. And then I can reduce that, so 8 goes in a both. This would be 9 over 2, and that would be the minimum height. 9 over 2, or 4.5, or 4.5. Any of those answers would be good. And centimeters. All right, so hopefully that wraps up the pyramids and cones. We'll spend some time reviewing on Monday.